given effect, for instance, 300 miles. What's that? It's a lot, it's a little. What's the meaning of this fact? It doesn't mean anything. This number only means something if you give context. And then you need dimensions. For instance, if you say a reservation costed 300 euros, that's a meaning. The number per street doesn't have. So in the data house, we usually will have a table, which is the fact table, which contains numbers like costs, things that you can aggregate and sum. And around this table will point to other information with given context. For instance, a reservation can be made in a hotel by a guest in a given day, maybe using a affiliate instead of the booking.com website. The important thing here is that we have a fact table with foreign keys pointing to all those different tables. Here in the hotel table, for instance, we will have the ID. This is a surrogate key. It's not the operational key. The operational key appears here. It's the hotel ID. This is the source ID. The name and all the information you can have about this hotel. And more information like city, country, all the information that could be split in other tables are merged, flattened in a single table. This will make the query much, much faster. And many people, when see this kind of design, city and country in the same table, they will think, perhaps we should do that, something like that. This makes sense in the operational system because you are always updating. If you want to update, for instance, the city, you just want to update here. You don't have to update hundreds or thousands of records. But remember that in the data house, we don't update data. The data house information that we entered there, it's important, it's historical. We just leave as is. So we don't do that in the data house. That's called snowflaking. When you start to break tables and sub-tables and sub-tables. That some authors defend this design with breaking the relationships, but in terms of performance, it's bad because when you need to make a query, you will have to do a lot of joins. The dimensional design, according to Ralph Kimball, is this force in the design that's not invented. It's just a natural force when you put the understandability and performance as the highest goals. Yes?
Why don't you have separate table for city and country where the reservation points to the city and the reservation points to the country?
That would be a
then you could select the city and it would go on part.
That would be a valid design, and in some contexts that would make sense if you think that the city and the country, the relationship between city and country and hotel can change. But since you know that the hotel is in a given place, in a given city, and a given country, it just makes easier for reporting if you put everything in the same table.
But you cannot make it that easy to query about what is going on down in November.
Yeah. If you do what you suggested, which is making a link from the foreign key from the fact table to the city and the country, that would work. But then we would start to have too many dimensions. It's not a common design to do like that. It's possible. We usually the dimensions are wide. You will see lots and lots of attributes in the dimension table. Instead of having a shallow dimension, you just one attribute, you have a lot of information. So another interesting question is, why do we have a day table? Why don't we just have a daytime attribute in the reservation? The important thing we want to know is that the reservation happened on a given day. Why don't we put daytime there? What's the use of a day table? The day table is a recommended design because there are many pieces of information that you don't get from SQL date functions. For instance, fiscal quarter, the season, in the case of Booking.com, we have the high season, low season. Major events, we had this year the eruption of volcano in Iceland. That was a major event. By having a separate date table, we can query things like, give me the sales during the year and please list the major events. What was in fact the impact of this event in our sales? So again, this is for reporting. Very important thing to do. One of the main advantages of this design is that queries, when you think about making a report from a traditional system, you have to do a lot of joins. Joins of joins of joins and more joins. If the tables are isolated, you have to cross several joins to get your information. In Data Warehouse, all the queries will look exactly like that. Select a given attribute, the fact you want to retrieve, so the commission we got, the sum of the commissions. What this means is, grouped by hotel name, give me all the commission. If you want to increase this or change, for instance, instead of hotel name, let's group by country. Just put here country, it works. If you want to add more information to your report, I want by country, by year, the sum of commission. We just add the attribute here. We add the joins, but it's just one level of join. This is the important thing. And finally, we add the attributes, the same attributes here, they are grouped by. More detailed information. I want to know the reservations by year, season, and country. Just add fields. If we have a web interface, for instance, you can just drag and drop the attributes, the dimensions, and this will always look like that. This is the beauty of the Data Warehouse design. The queries are much faster because we have less joins and we have opportunities to improve them. This is the template we have for any query. Actually, it's missing the where clause. We could, yeah.
Very big join.
Yeah, yeah. We could slice using a where clause. This is missing from the data. Usually we will have that, but always the same thing. the same template for all the queries we do guest data. So now going to how that ideas apply to the Perl data house toolkit. What are the goals of this project? The first goal is to describe the facts and dimensions of Perl. These facts and dimensions will be used to feed an ETL framework. We also will have a data house and an aggregate navigator. This will be the web-based application where you just have a fact, reservations, sales, or cancellations, whatever you consider a fact. And then you can just drag the attributes, so hotel name or hotel country or day or month, or you just select the attributes and you have the query. This will be the navigator. A description of in Perl, the description will be something like that. We create a dimension first with the name, the type. We identify natural keys. Slow change in dimensions. This is an important subject that must be treated by the ETL. This is related to changes in the dimensions. For instance, if one hotel is closed in a given part of time, and, we must somehow mark that in the data house. The same hotel can have different status during the life of the data house. Then we have the facts. One fact can point to some dimensions. And we can have some attributes. The effects usually are much simpler than the attributes. And instead of writing small scripts to do the ETL, we'll use this metadata. In the backbone, this is again the 70% of the work in the data house. Instead of writing small scripts, just a tool that will recognize the metadata about dimensions, facts, source systems, and do the processing, screening for data quality, take care of slowly changing dimensions, create aggregate tables, things like that. I'm going to talk now about the two things here, the changing dimensions. When a dimension changes, you can just overwrite it. For instance, there was a typo in the hotel name. You just overwrite it, just fix it. On the other hand, the hotel status changed. You want to preserve the history, so you create a new record in the data house and partition the history before and after. Aggregate tables. We have 130,000 reservation facts. Each fact is a record in the database per hotel guest day. On the other hand, if we aggregate this information, we have just one reservation fact per day. Suppose the sum of those reservation facts, let's say it's 1 million euros. We can store just that, 1 million euros